Hello all. So in this lecture we'll see that once we are done with ADF and uh, KPSS test, then we'll get to know that is this series a stationary or not. If it is not a stationary series, then what kind of changes we can make in the data so that it can become a stationary data. So um, yeah, so we'll see some techniques to make it as stationary. So let's say if I import the data, again it's a airline passenger. This data is what we did AD Fuller and KPSS test in the last class, and we get to know that this is not a stationary data, right? It's a non-stationary, so we have to make it stationary. So what we can do is, and we saw how to interpolate, like maybe if they give different thing, then that what we can do, right? So you can see detrended series you have to make, or different series you have to make, and then on that you have to try ADF and KPSS test. Now what is differencing, we'll cover that first. So difference is like you take the data, and for example my TF, DF is this, right? And from that specifically I need is a passenger, right? So this is my data. Now if I write diff of that, okay, I'll again plot. Okay, so what we are actually seeing here is you can kind of or let's say if I just df difference is what I'm storing here, uh, and that's how it is, and call it df. Okay, so yes, so what I did is I took 1118, and from that I subtracted 112 and I got 6. From 132 I subtracted 118, I got this. 129 I'm subtracting 132 and got this, right? So this is called a difference series from that. So what we are doing is our next term, right? So let's say yt is the next term. Okay, yt is the next term. From that we are subtracting yt uh, yt minus 1 from that, right? So let's say first point is like 1118, that is yt, the current point, and then from that I'm substituting previous value which is 112, and I'm getting 6 value, right? So similar thing I'll do for all of them. So this is called one level 1 differencing. Now there could be another, like what you can do is you can do differencing of this also, like whatever difference I got from differencing once, I take difference on again on that. So if this is also not a stationary, then I again take a difference, and then I'll see if it is it a stationary or not, right? So you can go further, but will not go beyond maybe 2. Just even if we don't get it, we'll try another methods, okay? Because getting the trend again, like once we do this, we, even if we were able to predict, we have to go back also to get the original value, right? We'll see what I mean by that, but just in case that up to 2 or 3 you go, then you should not do again mode. Now yeah, so that is what differencing is. So from that, if you drop the null value, then this how difference will look like it. So I lose a row for this, but that is okay. I'll usually not have this small data. I'll usually have a very huge data, and losing a row or not, or something is not a big loss. So if I able to make this as a trending detrended series, and if I will be able to get stationary data out of it, that is what my requirement is, right? So again on the difference series I'll do the df test, and now my p value is coming very close to 0.05. Maybe you can consider this, almost you can consider this as it has become a stationary according to ADF, right? So ADF earlier said, earlier it gave 99.99, if we have done that, so see ADF gave 0.99. From that we have reduced to almost very close, right? We are able to make it. So that's how you can, if you do the differencing, it might help you doing the, like I'm not saying always it will work, but you can try this. Another thing you can do is you can do some kind of transformations you can apply. So one transformation is you apply log function to it. So whatever y is, you pass it through this y log. Log of y you can take, or you can take square root of y. So just in case, remember that we have values in some range and we wanted to squish them, or we wanted to reduce them by something like some form of transformation. So we will not do exponential thing. It will even make it exponential. It will never be able to get, this stationarity from that, right? So we wanted to squish it, something like that, and that's why we will use log or square root, which will reduce the values, right? Another transformation is called box Cox. So what we do is we take a lambda which varies from -5 to 5. So this is a hyperparameter, and for this values we compute y, whatever y is, power lambda minus 1 divided by lambda if it is lambda is not 0. If it is 0, then it's a log y. So it's like you can say if it is lambda coming out to be 0, then for one case only, this log value we are going to use, right? So out of -5 to 5, if it is coming out to be 0, then for that I'll do this. Otherwise I can go with this. Okay. Now yeah, all values of lambda considered, an optimal value of for your data is selected. The optimal value is the one which results in the best approximation of a normal distribution curve. So from this you'll maybe get a curve, and you can compare that. If it's a normal distribution, that's what we wanted. But don't worry, like we will not have to plot this or anything. Just to understand what it is, you can maybe read about this, how it works. Okay. Statistics, how, if you wanted to go deep inside it. But as of our use case, we know that what we do is we do the transformation of data from this to this, and we get a stationary data. Okay, that's what our target is, that we wanted to get stationary data. Now this is log transformation, you can do this, and similarly on that also you can apply ADF test and get to see what is there. It didn't do much. So just in case, I tell you that this all transformation will work when we have high variance. If we have a trending, it will not be able to do much. But what you can see from our data is we don't have much variance. The variance is around, like it is there, but it is not so much variance. Sorry, I think I said it incorrect. It should be if there is low variance, then only this test will work. Sorry, it's another way around. If it's a low variance, then only this test will work. If it's a high variance, then the test will most likely don't work. So if it's a high variance, then you have to use any other form of transformation, but this transformation will not work. So this is only for if my data is having low variance, then this will work. Now currently I have high variance, so so that's why I'm getting a very high value of 0.9, right? Even though I applied logarithm on that. I can similarly do square root. So same thing you can do with square root here. You can write np.sqrt and it will work. Similarly, you can apply box Cox, but we are not going to write that equation. What we'll do is we'll say we'll import box Cox from SciPy. So SciPy has stats, and from stats we can import box Cox, and then we have to give that. Just to let you know that it will only work if the values are positive, right? So to get a positive value, I am running this. So if I just show you what it is just wherever the positive is there, right? So this is my condition. So currently I have all the positive values only. That's why it doesn't make much difference. But this is what I am doing for true false. This is a Boolean indexing, and then I am taking the data. So just so you know, if there is a negative value, then box Cox will not work. Okay. So take a positive value of this and it will work. Now yeah, so I have positive value, so I am taking BoxWorks, and it will automatically tell you what is lambda value you are going to get, right. So if I status, okay, so the lambda I got as 0.14. Okay, so it could be anything between -5 to 5, and it will be able to find what is lambda is there for you, and you apply Eddy Fuller test on BoxWorks values. So this will produce two outputs. One is lambda and one is BoxWorks values. Right. So BoxWorks value, and you can see I have done it, but again it is not much better because my data has very high variance. Again, like I'll cover again detrending. In last class we saw detrending this, but what you do is you import linear regression, then you take whatever is there in the, so okay, I'll show you what is this. When I train the linear regression model, I need some x values and y value is the prediction, right? So my prediction is already passengers, then what is my x value going to be? So what I'll do, I'll not give anything, I'll just say some numbers I'll give that, I want some numbers. So np.arrange, I'm taking that, and right, so length of df, I'm taking that, and I'm creating this as x. I'm saying that this is my x. For that, predict y, because the predictions is what we care about. We not likely care about what is input given to it, or what we need is we need this the prediction or this trending line, which will help us and make this data detrending, right? So that's why I can use this. Now to train the model, I need to so to train the data, I need to make it as a 2D array, right? So this is just 1D. I'll do reshape and write -1, comma 1, something like this, and you can see this is my 2D data, right? Now it's a 2D, and then I can do a linear regression. Earlier, if I do, I'll throw an error. sklearn does that. Now my y values are this. I'll fit the model. I'll predict the values and say that this is a trend, and from y I would have either write trend here, that is also okay. Model dot predict x, remove that, and this is called detrended line, and same thing, right? So we saw that we can plot this here, and what we can do is we can do the test also. So this test will say that due to the KPS says or ADF says that it is still non-stationary, but KPS says it's still stationary. So we what we saw is we can able to reduce it to some extent, but still we couldn't able to make it stationary. So we need to do bit more on that on this data. So maybe after this, what you can try is you can try differencing on this. So whatever you get after detrended, on detrended, try differencing, and then you can do it, right? So it is like a multi-level, but more or less what you have to take from this is that if you need to do any kind of transformation, this all transformation does exist, which you can apply it. So this 2-3 kind of transformation are only there. One is on differencing, one is the transformation using any form of function, log, square root, or box up, and another is you take remove trend from the data, and that's how you can do it. So one more thing is that you can remove seasons also from that seasonal data, but it is very difficult, like it's a little complex to explain, so I'll just skip it, but it is also that. Thank you. That's all for today's session.